Okay, so I'm going to make a quick video to help you to get through this skills test. It's titled Planet Hunting, and I'm going to share a screen with you. And this is going to be the same program you'll be running, or the same website you'll be visiting to do this activity. And so now you're seeing my screen. Now I've got a kind of zoomed in view of what the program winds up looking like. Again, to zoom in, all you have to do is kind of like what you normally do. In my case, I've got a roller on my mouse, and therefore I can kind of roll in, I can roll out. I sort of like this view because this allows me to see the sun, the Earth, as well as the interior planets, Mercury, Mars, Mercury and Venus, and then Mars, our exterior planet, but also one of the inner planets. So I'm going to start with this view, and you'll need to expand your view in order to include Jupiter and Saturn to complete the activity. Because again, we're going to deal with all the naked eye planets. But I just wanted to kind of show you some things. First of all, make sure you understand. In fact, I'm going to zoom in on the Earth a little bit to give you a closer view of the Earth. Let me pan over here a little bit. And I'm going to zoom in. Remember that the Earth is going around the sun. And if you zoom far enough in, you can actually get a view of the Earth. And notice as you get closer and closer in, you're going to see one side of the Earth that is illuminated, lit up, and the other side of the Earth that is not lit up. Well, that's because the side that's facing the sun is the lit up side, and the side that's not facing is the unilluminated side. Now, keep in mind that the Earth is rotating. In fact, it's rotating. Go ahead and draw this if I can. There we go. Let's see. The Earth is rotating in this direction, counterclockwise, as viewed from, we're viewing from above. We're viewing from above the Earth's geographic North Pole. The Earth is going this way, right? And therefore, if you can imagine a little dude standing here on the Earth, well, currently he is located where he's just going from the nighttime side of the Earth to the daytime side of the Earth. So what time is it for him? It's sunrise, right? And he would be looking at the sun in essentially his eastern horizon. Somewhere in the east, he's going to see the sun rising. Now imagine a dude standing right here. What is he experiencing? He's experiencing plenty of sunshine, right? The sun is high in his sky. It's noontime for him. And finally, when you imagine someone over here, or it could be the same person as long as you allow for time to pass. But notice that this guy, now he's going from the daytime side of the Earth down over to the nighttime side of the Earth. So when does it go from day to night? Sunset, right? And which way would he have to be looking in order to see the sun? He'd have to be looking toward the west, because we know the sun sets in the west. It doesn't really set, it's all due to the rotation of the Earth. But that's really important for you to understand the daytime side, nighttime side of the Earth, which directions you'll be looking at, because that's going to be really important for completing this activity. Let me go ahead and clear my drawings and zoom out here a little bit, just to go back to the view that I had earlier. Because the one thing that's going to help you in deciding how things look from your perspective, let me go and get there. So now we have, oops. Now I've got my sun, my Earth, Mercury, Venus, Mars. The thing that's going to help you the most is to essentially make imaginary lines between the planets, the planets and the Earth, as well as the Earth and the sun. So let me show you what I mean. Let me go ahead and draw some lines here. So if I make a connector between the Earth and the sun, that helps me decide. I can make also another kind of connector to bisect my Earth into a nighttime side, daytime side. That'll help you to, again, keep in mind the time of day, which direction you have to be looking in order to see the sun. But also keep in mind that in order to decide whether the different planets would be visible at different times of the day, I think it's useful to draw little lines here between the planets and the Earth to think about, okay, if I'm seeing the sun, would I also be seeing Mercury? If I'm seeing the sun, would I also be seeing Venus? And you can also do this with Mars. Now think about Mars. Mars is only going to be visible because it's outside of Earth's orbit, it's only going to be visible perhaps in the nighttime sky. Okay, so keep that in mind. You'd have to be on the nighttime side of the Earth in order to be seeing Mars. And think about where it would be, which horizon, or would it be high in the sky, that sort of thing. So these little bisectors, or these little connecting lines, will be helpful in helping you think about whether you'd be able to see any of these planets at all, and what time, and in which direction you'd have to be looking. Now keep in mind also that this particular scene here is for when I recorded this video, which would happen to be August 27th of 2018. I'll be using this same video for many of my classes in future semesters. You want to look at the sky for the day that you're doing this activity. Okay, so don't use my diagram to help you decide whether the planets are visible and in which direction. You want to use your own program. So fire up the program, it defaults to the current time, and then you'll make your decisions as to whether or not the planets are visible, and you'll be able to fill out the table that follows. Okay, so that pretty much wraps it up. So I'm going to go and end this recording. And again, if you have any questions, feel free to email your instructor who is teaching this section of the course.